Swayam Prabha. Digital India. Educated India.
Welcome friends to the second lecture of soil technology, and today we are going to talk about the one of the important aspects of soil science, that is weathering and soil formation. Now in the previous lecture, in the basic overview of soil, you have already seen what is soil, and we have discussed about the composition of the soil. Now remember, soil is a heterogeneous mixture of minerals, organic matter, and then microorganisms, macroorganisms, as well as soil water or soil solution and soil air. And if you see the composition of the soil, 50% of it are occupied, 50% of the soil is occupied by mineral matter and or the soil organic matter. However, the rest 50% is occupied are the pore space, and pore spaces are occupied by either air and soil solution. Now the soil organic matter is a very important aspect, although it is only 5% of the total soil. It takes, it plays very important role as far as the soil physical, chemical and biological properties are concerned, and it gives an indication of soil fertility status. We have discussed in brief about what is soil fertility and what are the macronutrients and micronutrients. Remember, nitrogen, phosphorus, potassium, calcium, magnesium, sulfur, these are the macronutrients. Among these macronutrients there are primary nutrients and secondary nutrients, and also there are some micronutrients. So these micronutrients are also indispensable for maintaining the plant life. However, they are required in a small quantity as compared to the macronutrients. We have discussed about the mineral fractions. Remember, the mineral fractions are basically composed of sand, silt and clay, whereas the sand is the coarsest fraction and clay is the finest fraction, whereas the intermediate fractions are known as the silt. Now sand and silt are having the similar chemical composition as the parent rock from which they develop, and whereas the clay has different chemical composition than the parent rock, and the sand, silt and clay are constituting the mineral fraction of the soil, and anything which is having the size greater than 2 millimeter are not considered as a soil material. Soil organic matter is composed of different also components. For example, fresh organic residues, as well as active fraction, that is decomposing organic residues, and also they have very less amount volumetric composition. Volumetric composition wise, they have very less fraction as soil microorganisms, but still that soil microorganisms are present in billions in the soil, in 1 gram of soil. For example, 1 gram of active soil contain 1 billion of bacteria. Apart from bacteria, actinomycetes, fungi, protozoa, nematodes and other macroorganisms are also present. Then we have talked about the soil water and why we call it a soil solution, and also we have talked about soil air. Then what is the basic difference between soil air composition and atmospheric air composition we have discussed. Now today we are going to talk about in details about the processes which are responsible for the soil formation. So if you ask me how soil forms, we know that all soil forms from rock, but there are two important processes which are responsible for the conversion of rock to fully grown soil. By fully grown soil, we are talking about the soils with fully mature profile. We have talked about the soil profile in the previous lecture. Remember, soil profile is a vertical section of the soil which shows the soil horizons and we have talked about several soil horizons like O horizon, A horizon, B horizon, and also C horizon, as well as bedrock. Now, there are two processes which are responsible for soil formation. The first one is called weathering process, and the second one is called soil pedogenesis. Now, what is weathering? Now, weathering is basically the disintegration and decomposition of rocks. Now, there are three types of weathering. One is called the physical weathering, another is called chemical weathering, and the third one is there, that is called biological weathering. Okay, so we have seen that the physical weathering, the another name of physical weathering is mechanical weathering, and chemical weathering is basically also known as decomposition, and biological weathering is basically a combination of both physical weathering and chemical weathering. And the second important process is known as soil pedogenesis. Now, pedogenesis basically consists of four important processes. First of all, additions, then losses, then transformation and translocation. So let us discuss them in detail. So let us first start with the weathering. Now, as I have told you that weathering is the disintegration and decomposition. So it is the combination of both disintegration and decomposition. Now, disintegration, remember, it is a physical term, so there is no change in chemical composition. However, the decomposition is basically the change in chemical composition. So, weathering is the disintegration and decomposition of rock at Earth's surface by the action of physical, chemical and biological activities. So, these disintegration and decomposition processes are mediated through different physical agents, chemical agents and biological agents and their activities. So, let us see what are those. So, but before that, let us remember that it involves both destruction and synthesis. Now, this disintegration process is responsible for destruction of the parent rock and reducing their size, and this decomposition process is responsible for synthesis of new products. Remember that the weathering is the precursor of photosynthesis. The pedogenesis process requires that weathering to be active, otherwise the pedogenesis process will not occur in the soil without this weathering process. So let us discuss in detail about how this soil forms due to weathering. Now let us consider that these are some parent rocks. So these parent rocks from which the soil forms, and these parent rocks are acted upon by different physical forces, and these physical forces we are going to talk in detail, we are going to discuss in details. Now these physical forces like temperature, water, frost activity, they basically helps in disintegration of this parent material, and basically these are actual bedrock underlying the soil layers. So this parent material are the fragmented parts of the rock from which the soil develops. So parent material is basically the stage 1 of soil formation. Now these parent materials initially these parent materials are initially acted upon by different physical agents due to physical weathering, and then different types of addition, alterations and losses due to pedogenesis process. As I have told you, they form these layers of the soil. Now, while these disintegration of physical weathering are going on, some fraction of this parent material undergoes chemical changes, and due to the chemical changes there is the formation of secondary minerals. The secondary minerals, by secondary minerals we basically denote clay minerals. Apart from that, there are some other minerals like iron oxides, aluminum oxides, calcium carbonate, which are also known as secondary minerals. So these secondary minerals and these primary minerals, the primary minerals are those minerals which are present in the parent rock as well as the sand and silt. So as you can see that due to the physical weathering process, these parent rocks or parent material basically reduces their size and goes ultimately to the and creates sand and silt size fractions, and the sand and silt undergoes different chemical changes to produce a new produce the new chemical structure of clay mineral. Now this clay mineral basically these clays as well as sand and silt, they mix with humus or other fractions of soil organic matter, and then they create different layers like topsoil layers of O horizon, and then below the O horizon they create this A horizon, B horizons, and other other horizons of the subsoil. So this is how the soil forms from the parent rocks through the action of both physical weathering and chemical weathering. Remember, this process is very slow. Even if it is very fast, it takes hundreds of years to develop 1 inch of a topsoil. So let us see these physical weathering, chemical weathering processes in details in our next slides. So one thing before discussing this physical weathering and chemical weathering, I should mention that based on based on where the soil originates, the soils are broadly classified into residual soil and transported soil. Now, what are these residual soil? Residual soils are the soils which form at the place of their original parent rock. Okay. Now, if you go to the western part of our country, if you see the black cotton soil of Maharashtra and Karnataka, these are the soils which develops over their parent rock. So they are the examples of residual soil. The other class is transported soil. Now, transported soil are given different names based on the transporting agents. Remember, once these parent materials weather away, they carried away from one place to another place by different physical forces like air and water, and depending on what is a carrying agent, then we name them differently. For example, alluvial soil, then colluvium soil, then aeolian or loess soil, then teal or moraine soil, then marine soil, and lacustrine soil. Remember, this alluvial, we call a soil is alluvial when the transporting agent is river. We call a soil is colluvium when the transporting agent is gravity. The aeolian and loess soil are formed due to transporting agents of air. The steel and moraine formed due to the transporting agents of glaciers, and marine, as the name suggests, it forms due to the transporting agent of ocean, whereas these lacustrine soils are formed due to the transporting activities of lakes. So you can see, depending on different types of transporting agents, we name these soil differently. So if you see some examples, so this is an example of moraine soils. So these moraine soils are basically formed due to the transporting activity of glaciers. When glaciers moves, this type of soil basically forms. Another type of soil which is widespread as far as the Indian soil are concerned, that is called alluvium. This alluvium is formed due to the transporting activities of rivers, and another is lacustrine. These lacustrine soil forms due to the transporting activities of lakes. This aeolian is formed due to the transporting agent of air, as you can see here. Colluvium soil formed due to the transporting activities of gravity, and these soils basically forms at the foots of different hilly regions. So if you remember, if you have a if you want to have a quick recap of the rock, there are three basic types of rock. One is called igneous rock, sedimentary rock, and metamorphic rock. Remember, igneous rocks are rocks which formed due to the solidification of magma, and the sedimentary rocks are those rocks which formed due to the solidification of different sediments, and these metamorphic rocks are the rocks which form due to the transformation of igneous rock and sedimentary rocks. So these rocks basically weather away to form the soil. So the first, as we have seen that the weathering is basically disintegration and decomposition of rock. This is an example of physical weathering, and so this weathering is part of a process of breakdown of rock and transport of the resulting materials. Now remember that this overall process is often referred to as erosion. Technically, erosion is the removal of the weathered material and is only part of the overall process. So the process is basically composed of 4 stages. So first process is weathering, or first stage is weathering, which is followed by erosion, then transport, and finally deposition process. Now these erosion, transport, and deposition are accomplished by agents such as wind, ice, and water, and we have already discussed the types of soil based on these transporting agents, right? So let us talk about the types of weathering. So if we consider the types of weathering, the first important type of weathering is physical or mechanical weathering, and the second one is chemical weathering or decomposition, and biological weathering is the third type. Now remember, it is kind of unique. So biological weathering is basically a combination of both physical weathering and chemical weathering. Now biological weathering is also can be divided into biochemical weathering as well as biological weathering. So let us focus first on the physical or mechanical weathering. Now, as the name suggests, this physical weathering is also known as the mechanical weathering because there is no chemical changes. It is also known as disintegration. So the basic idea behind this physical weathering is the reduction of the size. So here you cannot see any chemical composition change, just disintegration into smaller pieces. So if you consider this is a big rock, and this big rock is disintegrating into smaller fragments and ultimately creating the parent material, which is the first step of which is the stage 0 or stage 1 of soil formation. So these changes of size from the parent rocks to the parent material is accomplished by this mechanical weathering or disintegration, and you can see there is no change in chemical composition, only there is a change in the size of the material. Now what causes the mechanical weathering? Now there are several agents which are responsible for mechanical weathering. First of all, the temperature is one of the major factor of mechanical weathering because, as you know, due to the temperature variation, rock is a bad conductor of heat. So due to the temperature variation, the outer surface of the rocks get heated and the inner surface of the rock get not get it is not that it doesn't get heats up. So basically when there is a variation of the temperature, there is a temperature gradient which forms within a rock. So as a result of that, there is a rock expansion and contraction, and when there is a rock expansion and contraction, there is always chance of breakdown of the rocks. So this expansion and contraction of rocks due to the temperature gradient causes the exfoliation. I will show you the picture of exfoliation. Another name of this exfoliation is flaking. Apart from temperature, water is another important agent of mechanical weathering, and water, especially the flowing water, it is a important source of physical weathering, and it also decreases the size of the rocks. And another important aspect, another important agent of this mechanical weathering is frost. So frost wedging is a process through which the frost disintegrates the bigger rocks. So basically what happens, water seeps into the small cracks and freezes and expands. As we know that when water freezes, it increases its volume. So there is an expansion. As a result of expansion, it exerts a pressure, and as a result of that, the cracks within the rocks gets enlarged. So this type of disintegration is known as frost wedging, and this type of frost wedging you can see in the cracks in the sidewalk as well as potholes in the roads. So apart from that also there is some organic activity, that means these organic activities are caused by living things. For example, the plant roots can loosen the rock and make these cracks larger. For example, grasses in the sidewalk, as you can see, and this tremendous force which is exerted by these roots can basically pry apart this bigger rock. So this is called the root pry effect. Another important aspect is abrasion. Now abrasion is basically wearing away of rocks by particles carried by wind and water. I told you that water is one of the important factor or agent of physical weathering. So this wearing away of rocks by particles carried by wind and water creates this mechanical weathering. Now what happens, the rough edges of particles scrape off the part of the rocks, and rocks in a river bed are scraped by moving objects in the water, and as a result of that they become smooth. So you can see there is a change in size or shape. So this is a good example of mechanical weathering or disintegration. Now let us talk about this let us talk more about this thermal stress and their effect in the weathering. Now this thermal stress weathering, sometimes also called insulation weathering, results from expansion and contraction of rock caused by temperature changes. I told you that since rock is a bad conductor of heat, there is always a temperature gradient which occurs in a rock due to the temperature variation, and this temperature gradient causes the expansion and contraction of rock. For example, heating of rocks by sunlight or fires can cause expansion of their constituent minerals. Now as some minerals expand more than others, temperature changes set up differential stresses that eventually cause the rock to crack apart. Now because the outer surface of the rock is often warmer or colder than more protected inner portions, so some rock may weather by exfoliation, that is called the peeling away of outer layers. So this is an example of exfoliation process. So in the exfoliation process, what happens? In the exfoliation process, the outer part of the rocks get peeled away, and this occurs due to the expansion and contraction of the rock, and due to the thermal gradient. And this is one of the most important example of disintegration or physical or mechanical weathering. Now the thermal heat from wildfire also can cause significant weathering of rocks and boulders. So because heat can rapidly expand a boulder and thermal shock can occur. Now the differential expansion of a thermal gradient can be understood in terms of stress or strain equivalently, as you know. Now at some point the stress can exceed the strength of the material, causing a crack to form, and if nothing stops these cracks from propagating through the material, it will result in the object structure to fail. So you can see that how this temperature variation can accelerate this mechanical weathering of rocks, and as a result of this mechanical weathering there is reduction in size. So to form the sand and silt particles from the parent rock, the major process which is responsible is mechanical weathering, because you see the chemical composition of the rock as well as the sand and silt are same. They are having the primary minerals, the same primary minerals, and only the difference is there in the size, and this is mediated through mechanical weathering or disintegration. Now I'd like to show you some photograph of this mechanical weathering through water. As you can see, this is a good example of water driven disintegration process. And let us talk more about this frost weathering. Now this frost weathering, called ice wedging or cryofracturing, we have already talked about this frost wedging. So this ice wedging or cryofracturing is the collective name of several processes where ice is present. Now these processes include frost shattering, frost wedging, and freeze thaw weathering. So as you know that the water freezes and thaws, so that also creates mechanical pressure to break the parent rocks. So severe frost shattering produces huge piles of rocks fragments called scree, which may be located at the foot of mountain areas or along the slopes. So this is a very good picture of this frost wedging. As you can see, the water seeps into the cracks and then they expand, creating a huge pressure to break apart the rock. So this is called the frost wedging. As you can see, this is another picture of ice driven mechanical weathering. Just like as this frost wedging, when water forms this ice, it expands in volume and creates a huge pressure which breaks apart the rocks into smaller fragments. Okay, now thermal expansion due to the extreme range of temperature also can shatter rocks in desert environments, because in the desert region there is extreme climate. Extreme climate may be either high temperature or very low temperature, and due to this temperature variation there is some thermal expansion in the rocks of desert environment, and which creates this physical weathering. Now repeated soiling and shrinking of minerals with different expansion rate will also shatter the rocks. So you can see a good example of of a rock which shows a mechanical weathering or physical weathering. Now what is the implication of physical weathering? Why physical weathering is important? The physical weathering is important because it reduces the rock materials to smaller fragments that are easy to transport. You see one important thing that when we are decreasing the size of these rocks, for example, you see let us consider this is a rock with a area of square 6 square meter, and when we break this cubic rock into smaller parts, you can see the area is increasing, and also as we continue to break down the rocks, you can see we are getting 18 square meter, and finally we can get a area which is equivalent to 2.5 acres from this only 6 square meter surface area. So basically when we are decreasing the size, there is an increase in the surface area, and as we have discussed that chemical weathering is basically mediated through different chemical reaction. So as the size of the rock fragments are going down, we are getting more and more reactive surface which will undergo the chemical reaction. So basically it increases the export surface of the rock making it more vulnerable to further physical and chemical weathering. So this physical weathering is very important to before chemical weathering can start, because physical weathering improves or increases the surface area for subsequent chemical weathering. So we have covered the physical weathering. Let us talk about the chemical weathering. Now chemical weathering is composed of, chemical weathering can be discussed in terms of several processes. The first process is a hydration process. So hydration is basically the attachment of water molecules to crystalline structure of a rock, causing expansion and weakness. So as you can see, the hematite mineral is there in the soil, and when the water molecules is getting attached to the process, through the process of hydration, it is producing the ferrihydrite, changing the chemical composition of hematite. So the hematite has the chemical composition of Fe2O3, and due to the hydration process, it is changing into ferrihydrite process. So you can see there is a change in the chemical composition of the material. So this is as you know, the other name of chemical weathering is decomposition. So this is a perfect example of a decomposition process. The next important thing is hydrolysis. Now hydrolysis is basically the combination of the hydrogen and oxygen in water with rock to form new substances. So as you can see, this is a feldspar, which is an important rock, and when it reacts with water through hydrolysis process, it forms different other compound, and also this K plus comes into the solution, and this component is further undergoes this hydrolysis process, forming these alumina or aluminum oxides and also silicic acid. So this hydrolysis process is very important as far as the chemical weathering is concerned. I would say that it is the most important process as far as the chemical weathering is concerned, and you can see this this hydrolysis process is basically changing the whole chemical structure of a molecule and producing a totally new molecule. For example, we have started with this feldspar, and now at the end of this hydrolysis process, we are getting alumina, which is aluminum oxides, as well as silicic acid. So this is hydrolysis process. The next process is dissolution process. So this process basically helps in dissolution of the rocks. So it is strongly influenced by pH, surrounding pH and temperature. We have discussed in our previous class what is pH and how it impacts the soil formation. So the pH and temperature influences strongly this dissolution process. When water becomes saturated, the chemicals may precipitate out, forming evaporate deposits. For example, calcium carbonate, which also we know which is also known to us as calcite or limestone. Also, sodium chloride or common salt and calcium sulfate or gypsum are particularly vulnerable to solution weathering. For example, you can see here, this is calcium sulfate dihydrate, so it is a gypsum. So when gypsum reacts with water through the process of dissolution, so basically they dissolve and produces the calcium calcium ion, sulfate ion, and also water. So you can see this gypsum undergoes the dissolution process and dissociates into their component, that is calcium and sulfate. Okay, so this is another very good example of chemical weathering. There are some acid reactions or carbonations also. As you can see here, carbon dioxide basically accumulates in soil air due to the respiratory actions of root as well as the millions of microorganisms and macroorganisms which are present in the soil, and this carbon dioxide basically reacts with the water vapor which is present in the soil, forming this carbonic acid, and this carbonic acid, when it reacts with the secondary minerals like calcium carbonate or calcite, they can form these constituent calcium ion as well as the bicarbonate ion. So you can see again the chemical weathering process is mediated through these these acid like carbonic acid, and also you can see there is a carbonation process where this calcite is involved. Oxidation reduction or redox reaction is very important reaction for chemical weathering. As you can see, this is an example of this is the olivine, which is an example of primary mineral. So this is a ferromagnesium mineral because it contains both magnesium and iron. So this ferromagnesium minerals, when undergoes hydrolysis, it produces the serpentine, and then SiO2 and iron oxides. So these iron oxides, when it reacts with water and oxygen through oxidation process, it produces the goethite, which is a very important iron mineral which is present in the soil. So you can see here the oxidation process is responsible for converting these ferrous oxide to these ferric oxyhydroxides, or which is known as goethite. The another reaction is there that is called complexation. As you can see, the muscovite, this muscovite is reacting with oxalic acid and water and through the complexation process, and they are producing this potassium hydroxide, which is present in the solution, and also a complex of carbon, oxygen and aluminum, and also you can see this fraction is coming into the solution. So you can see this complexation process is also very important for breaking down the original primary mineral composition and forming a totally new and different mineral composition. So these are the important process of chemical weathering, and one thing you can clearly identify that in the physical weathering, when there is no change in chemical composition, in case of chemical weathering or decomposition process, there is a holistic change of chemical structure. So some examples, some photographs of chemical weathering. As you can see, this is a very good photograph of chemical weathering, and you can see that formation of some oxides at the base of this rock, and these oxides, these red color oxides, are forming due to these different types of chemical weathering process. Acid rain, as you know, it is a very important important environmental aspect. Now acid rain generally happens when that there are automobile exhaustion as well as carbon dioxide emission from different automobiles as well as different industries, and also nitrogen oxides also. So when these oxides of nitrogen, sulfur and carbon goes to the atmosphere, they reacts with the water vapor and producing some acids like nitric acid, sulfuric acid, and when these acids comes back to the earth's surface through rainfall, that is called acid rain. Now, acid rain is an important agent of chemical weathering. As you can see, it is basically changing the chemical nature of this statue, which is made of marble. So this acid rain, which is acidic in nature, also can create considerable chemical changes. So we have covered both physical weathering and chemical weathering. The third process is known as the biological weathering. Now remember that this biological weathering is basically the combination of physical weathering and chemical weathering. So it can be both chemical and mechanical in nature. Some examples of biological weathering are root split rocks apart, and also so the root produce acid that dissolves the rock. So when the root split rocks apart, that is an example of mechanical weathering, whereas when the root produced acids dissolve the rocks, that is an example of chemical weathering. Burrowing animals are also there. So these burrowing animals produces the channels within the soil, creating the mechanical weathering. So this is an example of mechanical weathering. As you can see, these vegetations or grasses are growing on the rocks to create this for to weather these rocks. So this is an example of biological weathering. Now, regarding the stability and weathering of soil minerals, remember that the relative resistance of a mineral to weathering process is determined by its internal structure, and it depends on the the strength of the atom or ion binding their neighboring ion in the crystal lattice of the mineral. Now, there are four major types of binding forces between atoms in the crystal. You can see one is called ionic, then second is homopolar, then metallic and van der Waals forces. Now, the bonds in the crystal structure of the soil materials are considered to be mostly ionic in nature. Now, the major coordination polyhedra in soils are basically two types. One is called aluminum octahedra, another is called silica tetrahedra. Now, we'll discuss more about this when we'll be discussing the inorganic soil components in our next lectures. But let us just believe that there are two major coordination polyhedra. You can see here, this is a silica tetrahedra. So here the silica atom in the center is basically surrounded by four oxygen atom, and when we draw this structure, it creates a tetrahedral shape. So that is why it is called silica tetrahedra. Another building block is known as aluminum octahedra, where these oxygen aluminum at the center is surrounded by 6 hydroxyl ion, creating the shape of an octahedron. So this silica tetrahedron and aluminum octahedron are the most important coordination polyhedra. Now remember that the silica tetrahedra arrange themselves in specialized manner to form the mineral structure. Same thing goes with the aluminum octahedra. Now both of these tetrahedra and octahedra, they can share the crystal edges, also faces or vertices, which are basically the point of intersects. So edge and face sharing reduces the distance between the ions and the polyhedron, and hence increase the repulsion between the ions with similar charges. So when there is an increase in the repulsion between the ions with the similar charges, obviously that destabilize the crystal structure. So we'll discuss this phenomena in details when we will be talking about the chemical composition of different inorganic components of the soil. Now remember, the major force for destabilization of an ionic crystal is considered the Coulombic repulsion force. This is the mathematical formula of Coulombic repulsion forces, where this F is the electric force, K is the Coulomb constant, Q1, Q2 are the charges, and R is the distance of separation. So we'll see these in details when we'll discuss the mineral structure. But just remember that these silica tetrahedra or aluminum octahedra, they join with another silica tetrahedra or aluminum octahedra by sharing their edges, faces or vertices, and when they are sharing their edge and face, that create more destabilization because of repulsion between the ions with the similar charges. Now, what are the byproducts of weathering? Well, the byproducts of the weathering are in general, first of all, detritus, which are solid fragments. So you can see the detritus, which are also which are basically the solid fragments. Then new minerals you can see, which are clays, iron oxide, etc. And these are formed due to the chemical weathering. And ions in solution, which is carried up by streams into lakes or oceans. So these are basically the byproducts of weathering. So if you consider individual minerals and their byproduct, we'll see that in case of ferromagnesium silicates, the major byproducts are iron oxides, clays, magnesium ion, and silica in solution. And feldspars, if you consider the feldspar, which is one of the most important primary mineral. The byproducts are clay minerals, calcium ions, potassium ions, sodium ions, and silica in solution. Then let us, if we consider quartz, the quartz does not chemically weather, not, they basically only abrades into smaller grains of quartz. So quartz is very chemically, they are very resistant to weathering. They only show some little bit of physical weathering. Calcite, in case of calcite, you can see the byproducts are calcium ion and carbonate ions in the solution. So you can see that when we start with some minerals, they produce different types of byproducts based on their mineral nature. So rates of weathering in general, the wetter the climate, the faster the weathering occurs. Okay, so in wet climates, the carbonates undergoes through the solution process or dissolution process. So they usually weather faster than silicates, which weathers through hydrolysis process, since solutioning requires more water than hydrolysis. So because of abundant amount of water, so in the wet climates, the dissolution of carbonates is more pronounced than the hydrolysis of the silicates. Now the opposite is true in case of arid and semi-arid climates, where carbonates like limestone usually weather more slowly than carbonates. So basically the mafic silicates weather more rapidly than felsic silicates. Now what are the mafic silicates? Mafic silicates is a term, mafic is a term which we use to denote the iron and magnesium content. So basically these are ferromagnesium silicates, and felsic silicates are the other silicates which are devoid of iron and magnesium. So remember that the mafic silicates weather more rapidly than felsic silicates, thus the ferromagnesium silicates weather rapidly into clays and iron oxides. Now feldspar weather more slowly, whereas quartz does not chemically weather. Quartz only shows some physical weathering, and this will give you more idea about what are the minerals which which are least resistant to weathering, and which are the minerals which are most resistant to weathering. So here we can see a sequence starting from olivine, then we are getting pyroxenes, amphiboles, biotites, so potassium feldspars, muscovite, quartz. So these are all the primary minerals, right? So these primary minerals are arranged here based on their sequence to be crystallized from the molten magma. So obviously this olivine crystallized initially from the molten magma, followed by pyroxene, amphiboles, biotites, potassium feldspars, and then muscovite, and quartz is the last mineral to crystallize from the molten magma. So this is called Bowen's reaction series. Okay. Now what is, okay, there is another called anorthite and oligoclase. These are feldspars also. So we can see that anorthite forms in the first stage of crystallization. So it is first to crystallize, followed by oligoclase, and then other potassium feldspar, muscovite, and quartz. So this is called the Bowen reaction series. Now another is called the Goldie stability series. Now Goldie stability series shows that those minerals which are last to crystallize are slowly weathering. So they shows the maximum resistant to weathering. So in this series, in this sequence, quartz will show the maximum resistant to weathering, and the minimum resistant to weathering will be shown by those minerals which are early to crystallize from the molten magma. So you can see anorthite and olivine are fast weathering as compared to quartz. So this weathering sequence, or the resistant to weathering will follow this sequence, and this is called Goldie stability series. So you can see Bowen's reaction series and Goldie stability series. Again, Bowen's reaction series shows the sequence of minerals which will crystallize from the molten magma, and Goldie stability series shows the resistance of the minerals to the weathering process. So this slide shows the weathering at a glance. So we are starting with the parent material, and the parent material is being acted upon by by frost and other physical agents like wind, then rain, then hail and ice, okay, and heat and cold, so thermal variations also. So you can see they are creating the mechanical weathering or physical weathering. As a result of mechanical weathering, they will produce the fine parent material. This parent material will be reacting with acids and moisture, and they will produce the chemical weathering. And this chemical weathering, and also there are some there will be some spontaneous weathering going on, and this fine parent material will produce this silt and sand and quartz, so sands are basically the quartz, so they will further reduce the size and produce the silt and sand. And due to this chemical weathering, they will produce the silica, and from this silica there will be formation of 3-layer clay and 2-layer clay. We'll discuss about this clay structure later in our coming lectures. Remember, for formation of the clay, it also requires the oxides of iron and alumina. Also, due to this chemical weathering, there will be minerals in the minerals or nutrients or ions in the solution. So you can see this is a complete picture of weathering which takes place for the formation of soil from the parent material. So we have considered the soil weathering. Let us consider the second step, that is soil formation. So weathering is done. Now fine. Now what is the next step? So remember, for to be qualified as a soil, it requires the formation of the soil profile or the horizon. So this horizon will not be formed unless the soil formation stages or the processes which are responsible for soil formation are not active. So soil formation is brought about by 4 basic pedogenic processes. We call them pedogenic processes. So the basic 4 pedogenic processes are addition, losses, transformation and translocation. Now what are the additions? So input of materials to the developing soil profile from outside sources. For example, the rain adds water, dust adds mineral, animal adds nutrients and organic matter, human adds fertilizer, and evaporation of groundwater adds soil. So all these are different types of addition into the soil. So these additions are required for development of specific horizon. For example, these animals, when they die, they will come into the soil and they will decompose and form these organic matter. When they will accumulate at the top of the soil, they will form the O horizon. Okay, so this is an example of addition based soil formation. Now the second is losses. Losses, for example, evaporation carries away water, erosion carries away soil particles, organic matter decomposition, and nutrients and mineral leach. So all this process of loss also helps in the formation of specific horizon. And these horizon, remember, some horizon you will see where there will be loss of clay particles, and some horizon you will see where there will be accumulation of the clay particles. So all these processes will form different horizons, like O horizon, A horizon, B horizons. Third important point is transformation, or important pedogenic process is transformation. Now process of modification and destruction of existing soil components, and this transformation results in the synthesis of new products. For example, weathering synthesizes secondary minerals from the primary minerals. We have just seen that how these clay minerals form from the sand and silt, which are composed of primary mineral. And weathering alters the size of the minerals. Mechanical weathering we have already seen. And dead leaves transform to humus. We have already discussed the humus. So the dead leaves, when they transform into the humus, that is also a important aspect of soil formation. And the final pedogenic process is translocation. So this translocation, horizontal or vertical movement of material. Unless this newly formed material translocate from one portion of the soil to another portion of the soil, we cannot see these vertical, we cannot see these horizon differentiation. For example, water translocated by gravity or capillary action, then evaporation translocates salts to surface, and organisms carry materials from one place to another place. So these are the examples of translocation which also helps in the soil formation. Now the last topic of this lecture is the factors affecting soil formation process. So it is basically similar environmental conditions yield basically, remember that the similar environmental condition yield similar types of soil. Now scientist Hans Jenny in 1941 given a equation, we call it equation of soil formation. So according to this equation, any soil property can be expressed in terms of as a function of 5 important factors. What are these factors? One is called CL, that is climate. O stands for organism, R stands for relief, P stands for parent material, and T stands for time. So this soil property at any particular soil property is a function of these 5 different factors. One is climate, organism, relief, that is relief means unevenness of the surface, and then parent material and time. So we can see that soil we see is a function of 5 factors. All these factors plays a very important role. For example, type of parent material, then what type of climate it is. It also it also plays very important role for soil formation. What type of organisms are there? What is the relief? Either it is flat or it is a hilly terrain. How much time? All these things are very important as far as the soil formation are concerned. So when all these factors will act upon these, when weathering will happen and all this pedogenous process like addition, losses, transformation, translocation will occur and will be controlled by these 5 factors, ultimately a time will come when we'll see a fully formed soil profile. And you can see this fully formed soil profile is showing the O horizon, A horizon, B horizon, and C and also R or bedrock. So this fully formed soil is basically an interplay of weathering and soil formation and other factors of soil formation. So guys, let us wrap up this lecture here. I hope that you have now a basic idea about how soil forms, and in the next lectures we'll be talking more about the chemical composition of soils and also the chemical composition of clay minerals, and what are the important aspects of their chemical nature, and what are the properties which are which depends on the chemical structure of clay mineral. So thank you. Let us meet in our next lecture.